Now, what is the concept of double hashing? We saw that in linear probing, in quadratic probing, the concept of clustering problem was coming into existence because we were only dealing with one hash function. Now, research was done and it was observed that if we use two hash functions to compute the value that where the element can be saved in our hash table, then the chances of this clustering becomes less, very less. So in double hashing we did what? We used the concept of two hash functions. First we used hash function 1 on our value key, and with that we multiplied j and hash function 2 on our value key. Now this j is an iterative element, like just like I, which we have used in our previous two methods. The value of I ranges from 0 to infinity, less like that. So here j is the iterative element, which the values of j will be from 0, then it will be incremented 1, 2, 3, 4 and so on. Suppose a sum is given where it is said that the hash 1 of k is k mod 13 and the hash 2 function on k is 7 minus k mod 7. These are the two hash functions, hash function 1 and hash function 2. These two hash functions is provided. J is, as we know, that from 0 we will start, and if it doesn't satisfy we will go on incrementing j by 1. And these are the four keys which have been provided, right? So what is our basic table? It will contain the key which is 18, 41, 22 and 44. Then we have hash function 1 on key and we have hash function 2 on key. Now, hash function 1 on key. Hash function 1 says that k mod 13. Now 18 mod 13 will give us how much? 13 divided by 8 is 1. So 18 minus will be 5. Remainder is 5. So 5. 41 mod 13, the remainder is 2. 22 mod 13, the remainder is 9, and 44 mod 13, the remainder is 5. So if we apply the hash function 1 on our keys respectively, these are the four values or the four remainders which we gave. These are the four hash values, hash function 1 values. Now we need to apply hash function 2 values on the same keys. So hash function 2 says 17 minus k is first is 18. 18 mod 7. Now we know 18 mod 7 is 18 divided by 7. It will go 2 times. So 18 minus 4, that is 4. So 7 minus 4. It will come as 4. So the answer is 3. So the hash function 2, if we applied on our first key, the answer is 3. For the second key, 7 minus k mod 7. So 7 minus our key is 41. So 41 mod 7. Right? So if we do this, this value will give us 6 and 7 minus 6 will give us 1. So 1. Similarly, if we apply hash function 2 on third key, it will give us 6, and we apply hash function 2 on fourth key, it will give us 5. So now we have got the key respective keys value and the respective hash function 1 values and the respective hash function 2 values. Now we will start doing what? We will start with probing our keys using this formula into our hash table or array. Now our hash table is of maximum size 13 because here n value is 7 and here n value is 13. So maximum size is 13. So So this is our hash table, and using now this formula for double hashing, we will start filling up these keys into our table. So first let us fill for the element 18. What does the value says? Hash function 1 for the value k, which is 5, plus j into. So at the very first instance, j will be our 0. So we will start j as 0 into hash function 2 for the value of key. Hash function 2 for 18 was 3, which will give us 5. Right? So what we will be doing? We will see that this 5 over here is empty. So we will do what? We will simply put the value of 18 in our index location 5. So here we have put the value of 18 in our index location 5. Fine. Now we will try to add our second key 41. Hash function 1 value was 2, j value is 0, and hash function second value is 1. So 2. We will see that yes, index location 2 is empty. So we will put this key 41 in index location 2. Now we will try to insert 22. Hash function 1 is 9 plus j value is 0 into hash function 2. So we see 9. We see that yes, 9th location is also empty. So we will put the value 22 in 9th location. Fourth is 44. Hash function of 44 is 5 plus j is 0 into hash function 2 of 5, which comes as 5. Now if we see location 5, 5th index is not empty. So we will do what? From j0, we will increment the value of j to 1 and again apply the same logic. So hash function 1 is 5 into j value is 1 into hash function 2 value. So 5 plus 5 is 10. We will see that yes, index location 10 is empty. So we can insert our key 44 in index location 10. Fine. So from j starting from 0 until index is empty, we can fill all the indices. So here the problem of what we were facing in quadratic probing, the problem was solved using the concept of double hashing. Now we will study the next concept, which is rehashing. Now rehashing was basically done to increase. There was no problem in double hashing, but rehashing was done to basically increase the size of our table. Okay. So we see that in linear probing, the concept of primary clustering was there. In quadratic probing, that disadvantage was eliminated, but the concept of secondary clustering was there. Now in double hashing, both the problems of primary clustering and secondary clustering were totally eliminated. So, but the problem is there that it has been seen that this algorithm efficiently works if the value of m is a prime number. So if the value of m are always prime number, the performance will increase, and if the value of m is not a prime number, the performance will decrease. So the algorithm or the performance of the algorithm is sensitive to the value of m. So this was the only drawback, but as such there is no drawback in double hashing. But it has been seen that collisions mainly occur when lot of free cells are not available. If our table size is small, then only chances of collisions will mostly occur. If our table size would have been large, then in either of the cases we will definitely find a free slot, or we will find more number of free slots to accommodate our elements. But if the table is already of smaller size, obviously there will be collision. Just in the case, suppose if I want to accommodate 50 people and if I use a single small room, there will be clustering. And if I increase the size of room, suppose if I increase the size of room from single room to the size of a double room, and if I try to accommodate 50 people over there, obviously the chances of clustering will be less. Similar concept, if I increase the size, more people can get accommodated efficiently, and if I decrease the size, clustering will be happening. So the concept of rehashing is we will increase the amount of the table size, we will increase the table size. So now we will study what rehashing is and what is this concept.